And here, unmute and shout. It's sometimes so. Actually, here I can tell a story that's going to lead us into uh, getting a session running. And so we're doing a session on math blocks. And with this group, I see that I could use a little bit more energy and get you moving and talking. And so with the thought of having a group of students that might not get engaged and wanting to get them engaged, I got them to stand up and go out to where we had a big flat area. And then I took a bunch of blocks and I threw them. It's in piles, just hundreds of blocks, just to let things go. And I think for maybe preteens and teenagers in the middle of the afternoon, this is not a bad start in that it can get them from in sort of a half sleep stage to, hey, wait, and now they start playing and doing something. Um, Unfortunately, the last time I did this was with a group of 7-year-olds. Do any of you work with second graders? I wish I could throw these things at you in big piles like this to get you moving and speaking because it's nice to get interaction. Nobody? Let's at least, oh, well, I did hear Trish, and so I do know that I'm getting some sound, but it's kind of fun to interact. And of course, when I did this with a group of 7-year-olds, it was like throwing a match into a big tub of gasoline. It just sort of turned chaos for a while where students were throwing math blocks and running around. And we had to get back control over the session. It's still kind of fun. Um, One of the things that I want to get across here at the beginning is a little bit of motivation. Part of our philosophy is we spend a lot of time talking about eh, enrichment and other activities that can be done. And you can't do just fun, but you shouldn't do no fun either. And so it's pretty common that you'll hear somebody say, I hate mathematics. You don't often hear somebody say, I hate movies or I hate basketball. And a little bit is often the way it's presented. If you've got a coach who's just making people do drill after drill after drill in basketball to the point where they hate it, that's probably not a good coach. Um, Math teachers have a real balancing act to do because there's certain amounts of things that people have to memorize, certain algorithms and routines that they need to get down, and that just takes practice. But it's well worth keeping the inspiration in the play. If you've got a group of students that are having fun, make much more progress than if you have a group of students that dread things. Another concept that goes with this is the concept of some people are just naturally good at geometry or numbers, or how does this happen? This naturally good comes because, the kid grabs the basketball at recess and just starts playing basketball because they have fun. And so they do it. Kids are exploring and doing what they like. Somebody said, how do you make the kids like and explore Scratch? part of it is I might make everybody do an introduction, but I like having sort of free and unstructured time sometimes throughout the day where there's an option of things. This is almost like the Montessori philosophy, if you've heard of it, where there's just different stations and you just let the kids have some time being kids. If you find that some kid starts making patterns with pattern blocks and just really explores making geometric shapes, drawing them, making them with all sorts of various models, after a while, that kid is going to have a natural intuition into geometry. It comes from this play. Um, so it's nice to have some questions and things to think about. So, one thing that if you just drop things out is just getting them started, getting them to play with things that are mathematical in nature, having bright colored things, things that have structure, things that can lead to questions around the classroom is all very, very useful. If we're playing with this, I'll show you some different ways to play with it in a second. Oops. What would you like me to do? Somebody shout out, and so I'll be your hands. If you had pattern blocks, you could get some out and play. I actually have a trick that I will share with that in just a second. But while I've got some blocks here, is there anything you want me to do with any of them? Oh, pardon me. Uh, wow. Make an enlarged hexagon with the shapes. Okay, great. How do I start making an enlarged? Maybe to do this because I think this camera is a little bit wonky. What I'm going to do is I'm going to show some software, which is a software solution to this problem that you could use if you don't have math blocks. And I'll talk about this because I know we have some teachers who are, sorry, I'll stop tweaking the camera, who work with really young students. We're just having the physical manipulatives in playing. We'll have other students where probably if you bring out pattern blocks to your high school students, a lot of them might roll their eyes and like, yeah, I played with these in the second grade, not be so into it. Or if they are into it, they might want to do something bigger that's hard to do with just a, box like this of pattern blocks. So something that helps here, let's see if I can get it, um, is I want to highlight something called Polypad, which I'm putting into the chat, which has many very cool features. One that we will, is first of all, it's absolutely free. And if you read the Desmos philosophy and what they want to do, they want to get rid of a culture of white supremacy. They want to make math freely available. They want to work with the communities. Their vision and what they want to do is just really a gorgeous thing. So this is a great company that I'm very comfortable and very happy sharing with you that's providing resources out to the world. And so if you are, I didn't check to see if this is going to work on a cell phone, but it will certainly work on a computer. And so what I'm going to do is I'm going to do a screen share and I'll just share the whole screen and set things up a little bit. Um, Video panel and there we go. And so if you have the URL from the chat, and you drop it into your browser, you'll get something that looks like this. If you don't have an account, signing up for an account, I recommend doing. We can probably look in and see what they have in the way of accounts for students. I would not be surprised if they have sort of moderated or ways that a teacher can control counts for students, as some organizations do. If not, but I might put this on full screen here, and I can pan this thing around like this. And you said make a hexagon, make a bigger hexagon out of hexagons. So which piece do you want me to start with? I can click on any of these. So do you want me to start with the yellow hexagon, orange square, blue? So tell me which piece to grab. Which, if if you make me, I can pick on people by name. It's nice if somebody just volunteers. So do we have a volunteer or do we need a voluntold? That sounds to me like we need a voluntold. So, uh, Shauna, are you there? Can you hear me?
Yeah, I can.
Okay.
Please
So
start
you
with the orange square.
start with the orange square. All right. So I'm going to click on it and I'll hit Control Copy. And I will go up here and hit Control Paste. So I just hit a orange square. So now we're trying to make a big hexagon was the challenge. So what do you want next? And there's no wrong answer. This is just playing with this stuff. Imagine that this was just that I just dumped my whole collection of blocks out on the table in front of you.
The yellow on top of the orange.
Put the yellow on top of the orange. All right, I like it. So Control Copy and Control Paste. And it sort of snaps to place when you do it. So now what? We're trying to make a bigger hexagon. I need more voluntolds. So I'll go to the next
Dave,
person.
Dave, can the same polygon be used twice?
Yeah, we can use,
It twice?
yeah.
Okay.
So is there a particular one you want to pull back? We're trying to make a larger hexagon.
I have mine here, my
Ah,
stuff, and I was trying to get ahead of you, but I don't think trying to make a hexagon.
uh-huh. So we're trying to Largo. I forgot your first name. I know we've met. Who are you? Is Largo?
I'm Terry Lynn. I
Carolyn.
teach
Yeah,
at,
Carolyn.
yeah,
So,
Rock.
okay, so Carolyn,
Um,
which color block do we want to add to this?
is the yellow able to um can you move it around?
Yeah. I mean, we can take these
Another
things that we
yellow
can
and then
just
put it
make
on the right side or left side, maybe.
on the left side, and I can even
Then
rotate.
turn it,
Use
yeah, then rotate it, yeah. Right, like right in there, yeah. Or no,
yeah,
maybe it
just
won't
like
work. I don't
30
know.
degrees. Yeah, and it'll
Some
just click. Sure.
maybe it won't. That
So,
maybe oh
so now what? You want another yellow, another orange?
I don't think it's gonna work. Just
You
kidding.
don't want another one? Well, okay, we can drag this over here.
I thought Carolyn meant only use one yellow.
only use what, well, which we can make a diagram with just one yellow. Of course, if we want a hexagon, it's like, okay, right here, here's a hexagon. Maybe the statement is it's only possible, that's the only hexagon you can make. You can't make a bigger hexagon. Do we think that's true?
I,
I
I,
think we can.
Okay.
yeah,
I think if you had, yeah, possibly, thinking,
One,
ooh,
two, three, four.
what, so use
put
a
that,
blue and then add the red.
So you want to add a red. Where do we want to add a red? To the picture that we've already got or to a new one?
A new yellow.
New yellow. Okay. So here, so actually the way I'll do this is I will put this down over here.
And
I
then
will,
red.
now I'm getting people, so I'm going to zoom out a little bit so we can see. And I'll grab a red and I'll do a
And
control
match,
copy and I will paste it. And what angle do we want it at?
so you want to match the small side of the red to the a side of the yellow
And
for all
it
of them.
just clicks. There's numbers of different systems that allow you to play with blocks online. This polypad, in my opinion, is the best. It's just lovely. So yeah, now what?
And then just do that for every side for the yellow.
Sure. In fact, after I've copied it, I can just hit Control V, Control
Yeah,
V to paste more. Oh, did I
And you
get
can
but
this?
just
but
drag one too from the red and just it'll pick up another one.
Yeah. So there's various controls here that allow us to do this, which there's going to be two questions coming up in a second. Let me finish doing this just because A, it's kind of fun and gee, this is, which hopefully it is fun. Yeah. Um, and that we would have got. Okay. So there we go. So we, in fact, just made a bigger hexagon with one. So I like tying things together. I wonder, does this have a text tool on it? Maybe not on this one, but so to connect this workshop with the last one, Danny was talking about inspiring students by saying funky things. And so it's impossible to make a hexagon with exactly 5 pieces. What do you say when I say that?
three, four, five, six. I think it's true.
You think it's true that you cannot
Yeah,
make a hexagon with exactly 5 pieces? Okay,
I
so
I can't seem to. I'm working on mine and it's not. It's like the more I try, the more pieces I need to use.
aha.
Could you
I don't know.
use maybe
Oh,
four, maybe
okay.
What is
two,
this? That sounded like a light bulb moment.
Yeah, if the
oh, let me
if
try.
you use that yellow hexagon on to one side instead of putting it in the center, I think I'm not sure. I'm trying to work this. I mean, a hexagon doesn't have to be perfect as long as it has six sides.
Oh, I love it. Yes. And so can we make something with six sides using five pieces?
Does
One,
it
two,
have
three.
to, does it have to fit perfectly?
It would be nice. So it would be nice to have the pieces snap together. And so here on this sheet, you see, which if
One,
I'm
two,
working with
three,
the
four,
physical
five, six.
blocks, it's nice to put them together.
And you said well,
Five.
I used five. I mean,
Oh,
one, two, three, four, five.
how did you do it? Which pieces? What did you start?
Okay, leave that yellow one there,
Okay.
and then put both red, one on top and one on bottom. No, the other way.
What do you
Flip it.
mean? Oh,
Flip it.
flip it.
Hmm. Oh,
Like
move.
that.
Yeah, like that. Uh-huh. And the other one on top. Okay, and the blue ones two blue go in. It could be two blue. Try it. Yep. And the other one on the other side. Well, one, two, three, four, five. 1, 2, 3, 4, 5, 6 sides with 5 pieces.
Awesome. So, in fact, the whole point about this is often this can be let's prove the teacher wrong, which I like this on a whole variety of levels. First of all, there's something where you get in a classroom environment, especially by the time students have been in school for a while, sixth, seventh, eighth grade, where, oh yeah, whatever the teacher says is right. It's like we're training people to just blindly trust what they hear and what they say, when exactly the opposite should be taking place. We should be teaching people to have this critical thinking ability to think and analyze and have confidence in themselves. That's really important. We want the kids to come away knowing that they're able to do anything. And so taking away the teacher from this pedestal down to let's put the kids up on the pedestal. And so if you make mistakes, say things that are wrong, it feels like, hey, wait, that's not supposed to happen. You certainly don't want to leave a wrong statement out there for so long that it becomes embedded and they think it's the truth. But at the start of a lesson, maybe even if they're a little bit older, if it rolls over and then they discover that, oh, wait, you made a mistake in the next lesson, would be okay. But by the end of the lesson, saying, hey, wait, no, I'm wrong, you're right. You can figure this out. And constructing examples, making things concrete. Mathematics often gets really abstract and people don't understand what it is or what it can be. If they can make something specific, it makes it so that humans understand it. And so here we made a hexagon, and actually I love the fact that it made you think out of the box on this one a little bit, because you constructed a hexagon that wasn't a regular hexagon. Often if I just say hexagon, people think of this shape where all of the edges and all of the angles are the same. But the definition of a hexagon is just something that has six sides. Period. And so this has six sides and five pieces. Now, we could still ask, hey, but wait, I thought you meant a regular hexagon. So certainly it's impossible to make a regular hexagon with five pieces. So what do we think? Is it impossible to make a regular hexagon with five pieces, or is it possible? We should be able to figure that out. Before we answer that question, there is a dichotomy of how we could run this. On one hand, we could split it up into small groups where we have this software and people could explore in smaller groups. It's getting people more active. On the other hand, if I say have breakout sessions and people spend 10 minutes, oh, I can't find the breakout session, I can't find the software, I can't share the screen, that's kind of wasting what we're doing a little bit. Um, so let me ask people to vote if they want breakout sessions, but the first class of do you want breakout sessions is yes, I want breakout sessions, and yes, I'm willing to be the note taker for my breakout session, and I will share my web browser with this polypad pattern block thing and do what people tell and come up with ideas to sort of note take. So if you are in the group that wants a breakout session and are really willing to lead the screen, please drop your name in the chat. And if we discover that nobody's willing to do this, well, okay, I'll do it. But if we got 3 or 4 people who are willing to do that or more, then we could split into breakout sessions. So the first is if it's possible, and it's only possible if we have session leaders. So any session leaders want to volunteer to do breakout sessions? So I believe so. Shauna asked that she would like a breakout session and wonders if we have the ability to share screens. I think that yes, if we split into breakout sessions, one person in each session can share the screen. So we're having, Clorinda's in her truck using Wi-Fi. Cool truck. We got Amahan, I don't know first name, saying that wants one. Shauna wants to do it, but didn't say whether she could lead. Carolyn would like a breakout, but doesn't want to be a leader, right? So far, the only breakout leader we have is me, which just leaves us all in one room, which is where we are. In order to have, so it's only a possibility if people step up to turn on the screen and do that. So I'll give it an extra minute. I'll take a pause and let people think a little bit later. Let's put it in the chat if you're willing to be a leader. I will continue just leading until we have enough people volunteering. It doesn't hurt, right? This is one of the actual joys about the exploration part of mathematics is it's scary, but maybe best to lead an exploration if you don't know the answer. The reason that's the case is if you know the answer, you're very tempted to tell people what it is before you're going to spoil the movie and spoil the story. The main reason that you want to know that it goes somewhere is you want to know that there's some interesting things that can be discovered. And so I'm going to try to do different sessions. So, Shauna is willing to lead. So now we have 2 sessions. If we get up to 4, so myself plus 3 others, I'll do breakouts. Until then, I think with 52 people online. So, okay, Terrelyn says she'll lead. She says she'll get on her computer. So send a text when you're on your computer. So now we're up to 3. If we get one more, we can do this. Does somebody with build a hexagon out of 5? How do we put pieces together? Do we see other pieces that might make, or you can change the question if you can't answer. So Terrelyn is on, so we've got Shauna, Terrelyn, and I. Any pieces that might fit together that could help get us a hexagon? Can you make a hexagon with less than 7 but more than one piece that's a regular hexagon.
Could you repeat the directions one more time, please?
So, can you make a hexagon using more than one piece, but less than 7 pieces? We have a regular hexagon with 7, and we have a regular hexagon with 1. And so I want to put a hexagon in between these two that will use more than 1, but less than 7. Yeah, I agree. It's actually having manipulatives is a really nice thing, especially when you're first getting started. But if you open this up on a browser, you could drag it along on your own. You can take this, and so yeah, I'm assuming for green. So Marianne sent a picture that I will open up in a
So in
random.
other words, Dave, you're asking use 6 pieces.
We'll use 6 or 5 or 4 or 3,
Neat.
and so it was just sent a file, so I'm going to open that up. Um, just this image. I just clicked the first place it went. Ah, so this is a hexagon with 5 pieces. So we've got one on 3 yellow and 3 blue. Uh-huh. So let's try to do some of these things. Um, so here I put, you said 3 yellow and 3 blue? 1,
3 yellow.
2,
Yes.
3. I'm guessing like this.
Yes.
And then 3 blue, which maybe
They go in the corners, yeah.
I like it. Things that I'll do here is I will group this together. I'll group this together. Then I can slide these pieces around a little bit. So we now have one, 6, and 7. In fact, let me take half a second and here I'll go to yeah. So here, I want to write what I view is a story about mathematics that I'll call Making Math. Let me hide my controls so I can get it out. And the first part is, and I won't stick them with numbers because you can do it at any stage. Notice and wonder. We've done some sessions with notice and wonder. Let me make this font much bigger. So you just start playing with things and looking and explore the world. It's kind of like the part of the scientific method. This is a phrase in teacher workshops. It's not just in our world. You can Google it and get lots of ideas about how to add this in. Um, Another thing that I'd like to see and emphasize is questions. Asking questions is super critical. When I get a middle school student to ask a question, I will write the question on the board. I'll write their name next to it. I might run and give them a high five. I want to really encourage them. So here we're at let me see if I bet I have a good way to do this. Sorry for the, yeah. All right. And so we're just starting to play and just letting kids play with things that they're engaged in, which partly depends upon age, on how complicated or what level of things you're doing. You might need to get fancier 3D models. You might need to get Legos. You might need to get different shapes. You might need to get bigger things. Having a menu of things that your students can explore is good. After they start playing, they'll really build intuition into what works and what doesn't by this play. And so we shouldn't underestimate how important that is. But then another step is ask questions. Can somebody think of a question that we're getting to here? So we've made one with 1, we've made one with 6, we've made one with 7.
So I was just wondering for older grades, could you maybe have this be a segue into a different science topic? Like would you see these in nature?
Yes. Do you see these in nature? Wow.
Or geology, I guess would be, but that's still nature.
Or, I love it. Let me actually do a couple things. Uh, some of you might be in Utah, yes? Right? So why did I say some of you might be in Utah and then show this on the right side of my screen?
Yeah.
Right. So this is the spot where I go get a jar of honey and start dripping that on the table, or maybe get some fry bread and honey and some powdered sugar out, right? The beehive state, do we see it in nature? Well, yeah, honeycomb. You certainly see hexes and lots of hexes. Let's see if we see devil's postpiling. Images. Ah, so see this picture? This is a mountain in California. This is not man-made. And you notice what the pattern is here? It's a bunch of hexagons. In fact, these hexagon tilings come up all over the place in nature, partly because nature likes being efficient. If you want to start squeezing things and filling up space, you might very well get things like hexagons, triangles, or squares, which we'll certainly explore this. In fact, when we're looking at this here, questions like this are, when will we ever use this? And so part of the answer to that is you can show applications and way it shows up in other aspects of life. That's not the only place. It's kind of like, hey, Boston Robotics has a machine that can shoot baskets and jump up on a table. Why should I learn basketball? Because it's fun. Right? Why should I think there's a calculator that can add? Why should I learn how to do math? Because having you yourself do things is entertaining. It helps you grow. There are certainly questions, since you brought it up, some topics I can see are scaling in proportions, fractions. Not all with the other, counting, induction. These are all topics that can be explored with these math blocks at different levels that I want to explore a little bit. Let me see how we're doing in the chat to see if we've got more volunteers. So somebody asked, put on Jamboard. I did think about making a Jamboard with this, and I looked it up, and Jamboard is actually going to be closed and they're going to delete everything. So it's still working now, but because of that, I wanted to do something different. And so here we've got something. This looks almost like the 21st century pattern blocks. Like this is a different type of pattern block, which I'll show people. Two reds, more than one piece, but less than 7. Here we've got 6, 1 red and 3 green. Aha. So 2 reds and 4 greens. Aha. 3 blues. Awesome. So let's make some of these here. And I'm going to ask for something that I'm still going to push on you to get a question out of this. And so we saw 2 reds.
Oh,
Yeah. I'm guessing that this is what people meant when they said the color, though there may be other patterns that could have been developed here that weren't just this. In fact, if we were, let me try this one more time. Okay. Right. Let me just comment that let me emphasize again, which this I think is actually a really important thing, because students often will get in the idea of just one model for something. And so realizing that a hexagon has 6 sides is the definition of a hexagon, I want to keep reminding them that this is a hexagon. It has 6 sides. I heard 3 blues. Sure. Go back to the chat. Right? Isn't that nice? So we've got 1, 2, 3. It may even turn out that we'll find more than one way to, here we've got another answer with 6. Maybe I'll just leave that there. 2 reds and 4 greens. Oh, that's an interesting model. How did we do that? So sometimes when you're trying to get things to click and you're zoomed in to so I'm not sure when you said 2 reds and 4 greens is the one that I'm making here on the screen, the one that you were thinking of?
You could use 2 blue on the end too.
I could use 2 blues on the end. Ah, that seems to be like an equal sign. So what was equal?
Yes, that's the pattern.
So is this a regular hexagon? This is certainly another hexagon.
Yeah.
To be regular, what does it have to have?
6 sides. Oh,
Wait, so let's go look. Just the red part of this has 6 sides,
mhm.
right? If I just do this, control copy. So there's a difference between a hexagon and a regular hexagon. This is a hexagon because it has 1, 2, 3, 4, 5, 6 sides. It's not a regular hexagon because a regular hexagon has a symmetry so that you can map any corner to any corner and any edge to any edge. For instance, let's do that with this one, and I will, ungroup. Then I will. So you see how I've got this blue in the upper right, and then there's an upper left? I can do this, and now the blue is in the upper left. You see how I was able to rotate that? And just by rotating this around, I can make any corner turn into any other corner. That's what a regular hexagon is. So, is this a regular hexagon? Could I turn this corner into this corner here? Could I turn the corner on the upper right to the corner on the bottom right?
Yeah.
Let's try it. If I do that, and the corners, we have this long top, this long bottom, and then these short sides. If I try to move, I can rotate this 60 degrees like this. And now the corner that was on the upper right is sort of to the right, but it's no longer, you see how this would not overlap the one that was next to it? I could try. Whoops. That's kind of where we started. It doesn't line up anymore. You see how that doesn't line up? This one is not a regular hexagon.
Is it because 2 of the sides are long and 2 are short?
Exactly,
That's
because
what
you
I'm-
can't make a long side turn into a short side. Saying that 2 sides are the same means I can translate and rotate and reflect one to line it up exactly with the other. That's what we mean by saying that two things are the same. That's a really important definition if you're teaching the 10th grade geometry class. It's the very notion of what congruence is. Do we have any 10th grade teachers? Anybody teaching geometry this semester?
I have up to middle school that I actually see. The high schoolers, I am consulting because I'm just the gifted teacher. But if you were the one who sent me all these blocks, I appreciate it because they've been having a blast with them.
Ah, so that must be Melanie.
This is Lisa. And I
Lisa.
don't know if you were the
Oh,
one who
oh,
sent them because
oh,
it just came from Amazon.
it was us. Yeah, yeah, yeah.
Thank
You
you,
asked. And so
because we're
I'm
using
very,
them. Yeah.
and so if you're a teacher and you're like, wait, they got blocks and I didn't. If you want blocks, if you want if you want supplies or puzzles or origami paper, send an email to us. That's part of the thing we can do. Here, Marianne has a lovely description with one with three and a little bit. What I like is there's something where we've subdivided this. You see how we can look at this red one over here, and we can replace that red one by a blue one and a green one. You see that these two things are the same, have the same overall shape. And so that means that we can take something, and in fact, we have that same idea that we can replace a yellow with two reds, or we can replace a yellow by three blues. This is going to allow us to get to different numbers of things. We could replace a blue with what could you replace a blue by? Can you see
Greens,
how
a
many
couple of
greens?
greens too, because three triangles would make the same shape as the red.
Ah, and so yeah. So
I think of it as equivalent. I don't know if that's
yes,
right.
yes. In fact, this is okay. It's limited in with when we're doing the pattern blocks to if I wanted to get a fraction of 1/7, it would be harder to do. I'll show you a way to do that using polypad, not just the polypad. Um, So, right. Hey, so here we're replacing, you see how this could be discovered by looking at this replacement here. So now we've got a 1, 2, 3, and 4. In fact, I'll put the 4 up. We can probably get a 5 just using this replacement idea. I'll drop it in. So I'd ask about 5. Can somebody see a way to? So now we've got 4 pieces. If we need more pieces using some of this replacement, can we get more pieces?
I remember kids doing something with the skinny beige colored
Yeah, we
diamond.
can certainly do things with the skinny beige colored. So we haven't played with that.
Parallelograms.
What?
What about this 6 triangles?
So 6 triangles, I love it. And so that was an image. I didn't copy it on the polypad over here. May have
Yeah.
shown us the 6 triangles. So can you get something between 4 and 6, thinking about an equivalence? This is kind of like leading you into equivalent fractions, right? If kids are playing with blocks and they're seeing this in first grade, the teachers that are looking for fractions in fourth grade will help you. We'll be very happy you did this. Oh, somebody's asking if I can make it with just 1 tab instead of 2. Yes, I'll do that. Is that better?
For me, it is.
Okay. So if you see what I mean,
Yes, that's better.
this is kind of like making a knife. This is, I take the blue piece and I cut it into 2 pieces, and so now I have 2 greens. Do you see how we could use that idea over here on this one? We can cut it, paste it, ungroup it. I could take this and just throw it away because I can replace 1 blue with 2 greens. See how that works? In fact, I wonder if this is going to allow us to group tiles. I'm going to try an experiment. Um,
If nothing else, when I dump a bucket of these on a table, I get very well-behaved little ones. And even we had student-led conferences, and I was working with sixth, seventh, and eighth, but the parent brought a little kindergarten boy who's known at school for being quite busy. He sat there the whole entire conference, must have been close to half an hour, just doing these and rearranging them and arranging them. And I
I
suspect
am
he's a kinder boy who's going to join my class soon.
I am super happy to hear that. Yeah, because that's the point on when I had my Windows document here that I'll do this just in full size. Um, Sort of, there's going to be different levels that I want you to get and explore with your students. And a very first level is going to be just playing with things. Because if you're playing with things that are of a mathematical nature, you won't find that math is something miserable. You'll find that it's something you like to play with. And in the process of playing, you're going to start noticing patterns. And this is where you get intuition. This is where you get people who are good at counting or good at geometry. Is it's people that, if they're building some spaceship model that takes funky pieces that only fit together in one way, but they love playing with spaceships, and they put this thing together back and forth. I don't care if it's Lego robotics or Gundam Transformer. It starts building intuition in a way where it's not this mean because you have to do this. It's because you notice that the second bullet here is ask questions. And so I want to get some questions here from you guys. Can you give me some sample questions about these blocks based on what we've been doing?
Is there a way to do decimals? Like I know how to do fractions, or what do I do once they've mastered that? I've got the gifted kids, and some of them are scoring 253 on the NWEA, and I've never seen that before. So I'm just looking for ways to advance it or challenge them.
Awesome. Um, Other mathematical questions that we can answer from others. I will certainly try to get some of these things. I'll do a quick blink at the schedule so I can monitor the time too. So I am going to 12:05. So, all right. So I've got a few more minutes. So in fact, maybe what I will do here is I will put a sub list of questions in that occurred to me. This is a little bit jumping us ahead. Um, so, can you make a regular hexagon with 9, with 17, with 51, with any number? So there's a whole scale here when I put into this question of, first of all, playing and discovering it. Just when you find one, it might be hard to see what the answer is, and your first impulse might be no, which in fact, I think when we first said 5, our impulse was no. Now we maybe start getting more of a feeling, and maybe you think, hey, we can do it. This step of passing from sort of smaller numbers into big but not too big numbers is really a pre-algebra step, because to answer a question with what happens when you do things with algebra is you're doing things with variables, but a prior step to that is doing things with big numbers to just see what the pattern is. And so I certainly, with the middle school teachers who are not yet doing algebra, but the students will be doing algebra in another 2 years, want you to look at doing something not just with one number, but doing it with a pattern of numbers that gets bigger, bigger, and bigger. Um, so let me show off using these pattern blocks as a fraction model. And so if I was going to do a fraction model, we could think, what is 1/3 plus 1/2? And I can easily make a model for 1/3 and 1/2. In fact, right here, I have a great model for 1/2. And maybe if I want to make it so that the part is there. So now we've got the 1/3 plus the 1/2. Well, if I want to know how much that is, I would need to decompose this so that we can put these things into common pieces. And so the 1/3 plus the 1/2 is going to be, well, here is the 1/2. Here is the 1/3. I can certainly drop this triangle in to finish the picture. But if I really want to know what this 1/3 plus 1/2 is, kind of what I want to do is make this so many parts. And if I want to cut these into so many parts, how many parts should I cut the 1/3 into? How many parts should I cut the 1/2 into so that they're all cut into parts of the same size? And so, can I make the red thing out of 2 blue things?
It would be too big.
It'd be too big. 2 blue things would be too big, and 1 blue thing is too small. And so I need to cut things into pieces a little bit. So how do I cut the blue thing up? This is
Green.
I cut the blue thing into 2 greens. And so I can make a green here and a green here. And then what about the red thing? What do I do with that? Maybe I'll change the color of this to a light blue for a second. Then what do I do with the red thing?
Three greens.
I cut it into three greens. So that means I'm going to have a green here and a green here and a green here. And in fact, if I do this right, I can probably make those turn into a lighter red color or a lighter purple. Like, oh, nope, I didn't want to do all of that purple. I want to do it. I mean, we can actually in the total, but I was trying to just, I'll make that a little bit more red, and then I'll drop in a green over here. This is kind of the fraction pi model, right? We make the fraction, so we have the one cookie or one piece of blue corn fry bread that we cut into three pieces. So each one of those rhombi is 1/3. We cut it into the traditional piece of fry bread into two pieces. And so now we see that each red is 1/2. And here we're adding a 1/3 plus 1/2. And we have to get it into common pieces. So we see the 1/3 and the 1/2, but we've cut them into six so that there's six pieces total. And we see that this is 5/6. You see how this is an example with pattern blocks of getting an equivalence of one block is the same as some collection of others that is directly leading in and giving the younger students intuition about fractions. Lisa asked about how to get decimals into the picture. And with decimals, you like cutting things into groups of 10. Which one of the really nice things about this polypad is I can group things together and copy groups. And so, for instance, after I have 5, I can just highlight, group, copy, and paste. And so here, this is going to be a very good setup if you're going to start saying what is a decimal, which is just fractions in an amount of 10. If you use things in rectangular blocks, if you need to have sevenths or if you need to have eighths, you can cut things into 7 pieces or into 10 pieces. Somehow just with the pattern blocks isn't as nice as anything, let me just go to straight up polypad.
I was wondering that those look like the way they have the pattern blocks come to school because the tens are bars, the hundreds are squares, and so on. So for using decimals, you'd want to stick with those kind of shapes.
Yeah, well, there's many different things that you can do. So on the website, I will make sure that it has this polypadamplify.com. I'll probably put just the amplify because this is what Desmos has become. If you've heard of Desmos, it has a huge number of games, software products, tools that people can use. And so inside Polypad, if you want to have if you want to do fractions like this with if you want a pi model of 10, I don't think that's quite 10, that's probably 9. Right? So right here, I've made a 10 gon. I can make custom polygons of any size I want. I can put a grid on to see if I want to see how things explore, either a dotted grid or I can do a graph paper grid. This program, in fact, this program will allow you to customize and you can make your own sort of back end to it and do things. And so it would be very easy to make fraction models in this program that were either based on circles or based on rectangles. That gives a large amount of freedom. Um, Another exploration that I would like, just in terms of geometry, is what happens when you do things like scaling. So here is a rectangle. I could take this rectangle, and if I want to make the edges become 4 times bigger, what happens? Well, I can control copy. I can put in paste and line it up. I can then paste and line it up and change the color a little bit. Uh, Here I've doubled the size of each edge. What happened to the area? What would happen if I tripled the size of each edge, which I can also do just by doing this. So when I go from 1 and I double the size, I suddenly have 4. When I triple the size, I suddenly have 9. And this pattern continues. These numbers, 1, 4, 9, later 16, are what are called squares, if you've seen them. And it's exactly because if I rescaled this rectangle, I bet I can do, I could make a square and I could do the same exact I could do the same exact argument of scaling and duplicating the square to build bigger squares where we would get 1 squared, 2 squared, 3 squared, 4 squared, which you could count and see. There's a lot of interesting explorations just in how things scale. Somehow the reason that you're getting 9 is it's really 3 times 3, because to get from this top picture to this bottom picture, we first stretched it in the horizontal direction, then we stretched it in the up and down direction. I will do just a really quick set of things because I see that I'm out of time. So one of the things that is really an amazing exploration is that you can take and make more complicated tiles and tilings by replacing a tile with something that looks like the same tile, but it is made out of pieces. And so we've done that in this one with the rectangles. We could do the same thing over here with triangles where I can take one triangle, turn it into a rectangle, then I can turn this rectangle into 9 copies of it, leaving this one fixed. If we wanted, we could repeat the process. Group and control copy. I'm not going to lay this all out, but the point of this is if I put 9 of these around here, if I did this rule again, where each rectangle turns into 9, it would get bigger, bigger, and bigger, and this gives us a way of tiling the plane. This is a very regular tiling, but there would be a different rule that you could do that I'd like to show, namely this rule here. This triangle is 4 dots this way and 2 dots this way, so the long edge is exactly twice as long as the short edge. So I could certainly put 2 of these to make a rectangle like this. I can flip one, put one on top and one here. This pattern of putting 4 where I just double the size is a very common pattern. But for some shapes, you can do more than just a multiple of 4. Here I've got the same, this green triangle is similar to this blue triangle. It's now at a different orientation, but it's obtained by copying. Now we could do this rule again, where each time we see a triangle like this, I put another one across the hypotenuse to make a rectangle. So I could put another one down here to make a rectangle. Then once I have that rectangle on top of the original one, I put another one up here. Then I put another one over on the end of the rectangle. And then I put another one at the end of the whole shape. And if I do that, this will become even bigger. Let your students explore using this rule where you replace each triangle by 5 copies of the triangle oriented like this, and it'll make an amazing pattern. In this case, this pattern is going to duplicate this angle at this triangle is going to keep rolling around and around, just like the triangle moved from here to now the angle moved to here. So we switched by that much. And this angle is an irrational angle. You'll get every angle of triangle appearing in the limit. Another one that was sort of like this, that makes a really cool sort of Lego-like piece, is here I started with a pentagon. And the side length is 1. If I go across 2 vertices, that distance is called the golden ratio. This is 1 plus the golden ratio. This is 1 plus the 2 times the golden ratio. And I can start making shapes with those. Like here, I've made 3 different shapes that I then copied. And then using the custom tile tool, I could fill them in. And I could then start copying and putting them together. If you're using the rule where, and then I'm going to pause here, the piece on the left turns into the piece on the right. If you repeat this, you get this amazing configuration of tiles. I'm going to stop my screen share now because I've been going for an hour and 15 minutes. I'll open up and see what people have put in the chat in case there are things, and see if there are any questions or requests.
I just wanted to mention, I had a 4th grader yet in the middle of the week say, I know about square roots. And then she said, because it means that number and itself. She says, so that 81 would be the square, 9 would be the square root of 80, on and on and on she was going. But I wished at the time I had had a visual, you know what I mean? Because when you did the 5, 6 thing, I saw the picture in my brain and knew that there was 1 out of the 6 missing. So I just said 5, 6. I didn't sit here and figure it out. And
Yeah.
that's what I want from these guys,
Yeah.
if they can. Some of them can see it, and that's why I find this fascinating. Other ones need the algorithm, like my husband.
Yeah.